Okay, we're still on C12, working with properties of graphs. Specifically today, our learning target is I can find extrema on a closed interval. Okay, I can find all of the extreme values, the maximums and the minimums on a closed interval. All right, and we're going to work through a couple of the examples in the book together. Post those on video there, and hopefully it'll be beneficial to you. You also have the book to refer to if you need to go back to it. Okay, so it says find the extrema of f of x equals 3x to the fourth minus 4x to the third. Okay, again, this is just example number 2. 3x to the fourth minus 4x to the third on the interval -1, 2. So find the extrema of that function on the interval, the closed interval, -1, 2.
Is it closed just because of the brackets?
Yeah. Yep.
Wouldn't it be 0 and what?
Extrema, if they occur, happen at either the endpoints or at where the derivative equals 0. Okay. The reason they could happen at endpoints is because there's a potential where the highest point on the graph is way over here to the right or way to the left, but not necessarily where that would represent where a derivative equals 0. Okay. But we're not really sure since we don't have the picture of this graph right in front of us right now. Sure, you could graph it and look at it to verify some of our answers, but you really don't even need to. All right? So, the first thing I would do is I would find your critical numbers, just like we've been doing, right?
It's a pretty good idea.
So, f prime of x would equal
12x to the third minus 12x to the squared.
okay,
Hey, quit it.
12x to the third
It's a good day off.
minus 12x squared.
I got 0 and 1.
Then we
Please stop.
I appreciate that.
set it equal to 0. What would you do next?
12x squared.
Take out a 12x.
Take out a 12x squared, factor out the greatest common factor of 12x squared.
You need to
Left with x minus 1.
So 0 and 1.
Set both factors equal to 0 and solve. If you set 12x squared equal to 0, you're going to get x equals 0. If you set x minus 1 equal to 0, you're going to get x equals 1.
Yep.
So x equals 0 and x equals 1. I didn't show my steps there. I'm telling you though right now, so if you watch it again later, 12x squared, if you set that equal to 0 and solve for x, you'll get x equals 0. If you set this equal to 0 and solve, you'll get x equals 1. Those are our critical numbers. Okay, yes?
Then would we solve for -1 and 2?
Yep.
Okay.
Okay, now to determine where our extreme values are, our maximums and mins, we need to see what the y values are at both of these locations and at both endpoints. Okay, you have to check both endpoints just in case the graph is the highest at the very left or the very right, or the lowest at the very left or the right. These are just maybe where we get like a relative maximum or something like that going on, right?
So how is this different from just a horizontal tangent line?
Okay.
So it's like we're solving it the same way.
Oh, we are very much solving it very similarly, but because we're on just a specific closed interval, we're only looking at this part of the graph, and we're going to find the max and min on that closed interval is all, not just any random horizontal tangent lines. Bryce?
When you put the critical numbers back in, is it for the original or
Yes. Yep. Put it back in the original function to see what the y value is on the graph. So we want to use the endpoints, and we want to use the critical numbers as our x values. All right. So f of -1, there's our first endpoint.
Is 1.
That'd be 1 times 3 is 3. Be -1. Would that be 7?
Oh, yeah, that's why.
Okay. So f of -1 would be 7. We gotta test our first critical point, f of 0. That would be 0. Okay? Then we'll test 1.
That one would be -1.
That would be -1. And then let's check 2, because that's our other endpoint. 48. 2. 16.
Mhm.
It says it.
Oh. It's not good.
Okay?
So do you just check those order lowest highest? Is that why you did it in that certain order?
Yep. So what we know then is these are our potential locations for minimums or maximums. Okay? Now, you can definitely see where the highest value is located. Alright? So this is going to be your maximum then. Okay? Pretty simple.
216.
And then you can also see where your lowest value is.
1 -1.
Okay? And that's right here. So there is your minimum. And to give you a little visual aid, the graph is here on page 167. Okay? So you can see that at -1, the graph is here. It works its way down. Now, we do find a horizontal tangent line at 0, 0, but it doesn't change direction. After it levels out at 0, 0, it continues to decrease. So it didn't come back up at 0, 0. It leveled out. We had a horizontal tangent at 0, 0, then it continued on down to 1, -1 before it went back up to 216. Okay? So visually you can kind of verify, okay, where's the lowest value on the graph? At 1, -1. Where's the highest value on the graph? 216. Okay? But strictly you didn't even need the graph to tell you that. You can identify them by simply looking at the y values of both your critical points and the endpoints.
Is it always gonna be on a closed interval?
Yes. Yep. Because if it wasn't a closed interval, you wouldn't necessarily
Yeah.
have a particular max or min, because it get to an open circle, well, you can't say what the max is at that point. Yep. There's 2 more on the next page. I want you to look at those, and maybe I'll work through one of them with you. Okay? They're both unique. The last one is trig, and I know that sometimes can be a little bit tough for people, alright? But it's the same concept, the same process. You can see the workout, okay? The one above it is interesting because some of the critical points weren't necessarily where the derivative was equal to 0, but was where the derivative was undefined, or you couldn't evaluate the derivative at a given x value. So that one's unique in that sense, okay? Do you guys care which one we work through? I mean, obviously it works in the book, but if there's one that I can...
Just do both.
Okay, we can do both, that's fine. Okay. Those of you that think you got everything, and have it figured out and want to just work, we are on page 169.
That doesn't look like that.
Thank you, Kyle. I do get a lunch 15 minutes.
You're supposed to eat.
Yeah, not.
Does it look like I have a problem eating
No.
quickly?
It
You
doesn't
don't
look you have a
like
problem eating.
Kyle.
Hey, that.
That's in the video now.
Kyle
Everybody will notice on the video that I have abusive students.
Kyle
Make fun of me.
I'll always be.
Those of you that do think you have it figured out and you want to start page 169, 17 through 26, 33, and 35, if you know the process, you know what you need to do, but I will go ahead and work out those other 2. Okay? 17 through 26, 33, 35.
Sign out.
Wait, hold that.
Hurry up.
Alright, Bryce.
17 through 26, 33, 35.
Alright.
Okay. So I'll work through it.
Grumpy. I'm gonna narrate the videos. With a British accent.
Do it.
Make it like a National Geographic film.
I'll work through examples 3 and 4 with you. I'll do it fairly quickly so the video doesn't go super long, but stop me if you have questions. So f of x equals 2x minus 3x to the 2/3 power. And this time we're on the interval -1, 3. And again, all we're doing is we're finding the critical numbers and testing the critical numbers and the endpoints to see where we have a max or a minimum on that closed interval. Okay, and because it is a closed interval, there is definitely both a max and a minimum value. Derivative, what do we got? 2.
2/3, 3.
What's 2/3 times 3?
It'll be 2x.
Negative 1/3.
Okay. 2x to the -1/3.
Dang, how did we do that?
2/3 times 3
Yeah.
is 2. And then x raised to 1 less power.
You're not in this.
Okay? Alright. Then we want to set that equal to 0 to solve. So 2 minus. I'll write it. So subtract 2.
Okay. Now what?
We don't want it staying equal to 0.
Wait.
We did. Right here.
I know, but I said staying equal.
Yeah.
Oh,
Can you divide by negative?
could.
Can you just divide by
Well, I mean, there's only one x here, so I think you can get it by itself, but, I mean, I suppose you could have done some sort of factoring. Divide both sides by -2?
Yeah.
Okay. X to the -1/3 equals 1.
Yeah. And cube rooted?
Would it be 1 over x to the 1/3 power? Or 1 over
Take all of them to the third power.
Would you multiply it? No. You-
Couple things. Tori, you said
You just take it to the first one.
negative.
Negative 3, yeah.
To get rid of the
Raise
negative.
both sides to the -3 power. Because when you raise a power to a power, what do you do with power? It's multiply. And what's -1/3 times -3?
3, 1.
1, right? Yeah. Okay. So you raise both sides to the -3 power, you'll get x by itself. Okay? Some people don't see it that way, some people don't work that way with fractions and understand that. Okay? So if you want to, do this. Okay? Now, 1 divided, I mean, I think you're going to see what the answer is here, but let's say you had this, so you move that down to the bottom, then what might you do, I guess? What? Cross multiply, that could definitely work. So then you have x to the 1/3 equals 1. You're thinking way too hard right now, but
Wait, how would you cross
Because it's 1 over 1. 1 is 1 over 1. Can you work out the multiplying?
Why wouldn't you read?
You should just raise it to the -30.
Now what do we do?
how do I get rid of a 1/3 power?
Cube
Cube it. Not cube root it. That is a cube root.
Ah.
That is a x to the 1/3 power is a cube root. So cube both sides, and you'll get x equals 1. Now, to be honest, okay,
But how is it?
what number raised to, I guess, 1 raised to anything is always 1. So I kind of knew right here that x equals 1 was the answer.
Doesn't equal
1 to the 7th is 1. 1 to the half is 1. 1 to the 8th is 1. Okay? 1 raised to anything is 1.
So you're just wasting my time.
Jeez.
Whoa!
Jesus.
John is taking up space in the steel trap.
Bailey, whatever were you asking for before?
Work through like how you would do it if you were to multiply by -3.
You mean just raise both sides to the -3? This to the -3, that just cancels out and you have x. do that on your calculator, 1 to the negative 3 power on your calculator, and you'll get 1. Does that make sense? Okay. Anything else on the algebra?
So there's only one critical.
Now, hold on here, okay? There is a value of x that is not defined. There is a number you could not plug in for x.
2 odd.
0. X cannot be 0. Because
It's on the denominator.
this is the same thing as this, correct? What number can you not have in the denominator? 0. So f prime of 0 is undefined, so that also makes 0 a critical point.
I thought 0 raised to anything was 0.
John.
Yes, except
So-
0.
Alright, yes. So 0 raised to the negative 1/3 is anything.
No, it's
It's zero.
0.
You
'Cause
said
what's the
zero.
cube, what's the
Over
cubed
zero.
root of,
Hurry up, let's go. I got.
what's the cubed root of
I'll talk to you
0?
about it later.
Okay, alright, I want to get through this and not have a 40-minute video. Okay, so,
I'm just trying to make.
we definitely can't have 0 here, so 0 is a critical point because that is a value that if you would plug into the derivative, you get undefined, okay? So 0 is a critical number, and 1 was a critical number, okay? So those are our critical numbers we need to check. These are the endpoints we need to check, okay? So f of negative 1, I'm going to cheat and use the book here. F of negative 1 is negative 5. F of 0 is 0. F of 1 was negative 1. And f of 3 was roughly negative 0.24. Okay? So then you look at those, negatives, negative, negative. So here is your maximum value, and here is your minimum value. So on that given interval, negative 1, negative 5 is your min, 0, 0 is your max. Very important that you recognize when the derivative is undefined, otherwise you would not have found that maximum. You would not have identified 0 as a potential critical point.
So anything that's undefined is a critical point.
Critical point. You watched yesterday's, okay? Critical values occur when the derivative equals 0 or when the derivative is undefined. That's how you find your critical numbers. Okay? Anything else on this one?
Nope, just the last one.
Okay? Last one, just more trig.
Wait, go back to that. How is the bottom one of the minimum? Oh, it's 0.24.
Yeah, negative 0.24.
Oh, I didn't see the little dot.
Yep.
Alright.
Alright, you good?
Silly guys.
Nice try.
Okay, we got 2 sine minus cosine 2x. Good practice here, derivative. 2 cosine x. The derivative of cosine 2x would be
Sine 2x.
Sine-
Times 2.
negative sine 2x times 2, or like you were going to say,
2 plus.
so plus 2 sine 2x. Chain rule. Derivative of cosine 2x would be negative sine 2x times 2.
Times 2.
So then you got a minus a negative, that makes it a plus, and then you got a sine 2x times 2. Well, I just put the 2 in the front instead of putting the 2 at the back. Okay?
Got it.
Alright. Yeah, this one's fun. Double angle identity.
What?
What is that?
We had a cheat sheet for that. No, we didn't. No, we didn't. We didn't. Except we did, we just weren't allowed to use it, right? Didn't we in products maybe?
Wasn't it 2 sine x cosine x?
Yeah.
I don't know. Sure.
QT shot last year?
I got a number too.
Email Pettit.
I know.
It is.
Taught last year.
Right, it is.
Please tell me.
I was right.
You don't have to know that.
Aren't you just so smug about it?
I wasn't very confident, was I?
That's what we want.
Will this have any chance of being like a double angle?
I would give you the double angle identity if
Alright.
you needed to do it on a test.
I remember them all.
You didn't remember it.
That's
It's all designed for traffic.
Yep.
Didn't see that.
But if you would get to this point, I think this is something you definitely can be able to do. What do you think?
We
Take
should
out
do
a
it a lot.
cosine X.
Take out a 2 cosine x.
God, I'm so smart.
1 plus 2 sine x. Now you factored it. What do you do with both factors? Set them equal to 0 and solve. Set this equal to 0, you'll get simply cosine x equals 0. I'm skipping a step there, okay? I'd set that equal to 0, divide both sides by 2, and I get cosine x equals 0. I'm going to skip some steps here because I'm running out of room. If I set that equal to 0, I'd subtract 1 and divide by 2, I'd get a negative 1/2. So sine x equals negative 1/2.
You're gonna
Yeah.
When is cosine of x equal to 0? Pi over 2, 3 pi over 2. Did it give us an interval here?
Yes,
Yeah,
it did.
0 to 2 pi. So we got pi over 2 and 3 pi over 2 for these x values. When is sine equal to negative 1/2? We did that earlier today.
7 pi over 6.
7 pi over 6.
11 pi over
6. 11 pi
That's
over
over
6.
That boy.
I'll leave
So-
the chat.
So yeah, so this one's pretty fun here. You'd have to plug in 0, pi over 2, 3 pi over 2, 7 pi over 6, 11 pi over 6, and 2 pi. See what all those values are. You can kind of see it right there on page 168. There were 2 minimums. There was 2 times where the value was negative 3/2. So therefore there are 2 minimums, and there was 1 maximum up there at 3. So, but same idea, same process. Okay? Little review on some trig. So,
Is that your back?
everybody get the idea? Finding extrema real quick.
Yep.
Find extrema. Do the derivative. Set it equal to 0. Find the critical points. Test the critical points and the endpoints. See where the biggest number and smallest number are.
Got it.
So when we're looking at max min, it's y value.